Dr. Kanojiya, Amarpal Kanojiya. So he is assistant professor in electrical engineering department. So MIT. So he is very world experience within the energy auditing, and he's also worked in the Center for Power and Renewable Energy Sources and CENT, and he has a vast experience in the energy auditing field, and he also works as a certified energy auditor for the Energy Conservation Awareness Program. So that is organized by the GEDA Gandhinagar, and he has that over 2 years experience. I hope this session will be very useful to the all the students as well as the faculty members. So those who are interested in the energy editing field and the solar energy field, it is going to be very useful. So I request all the participants to listen the session carefully, and the session will have the 1 hour session, and after that we have the 15 minutes question and hour Q&A sessions. And thank you so much. And I request Dr. Amarpal sir to start the presentation.
Sir, you can start the presentation now.
Hello.
Yes, sir, you can start the presentation, sir.
Right. Good afternoon, everyone. Now, today my topic is introduction to. Actually, there is a voice problem. Hello.
Yes, it is. It is a resound, sir.
From my side.
Yes, sir. From your end, some resound is there. Let me check.
Hello.
Yeah, you can check now, sir.
Hello. Okay. Now, actually, there is only one mic on from my side. Wait. Hello.
Sir, I think your both mics are on. You can see if you're in your system, if you have a mic, you can close that and you can talk on phone.
Okay. Wait a minute.
Now I think you can unmute yourself, sir, and you can start, sir. Hello, sir.
Hello. I'm audible.
Yes, sir.
Yes, sir, you are audible. You are not audible, sir, now.
Hello.
Yes, sir, now you are audible.
Hello.
Yes, sir, now you are audible, sir.
There is a voice problem actually. Wait.
Okay, okay, sir, now it is clear, sir. Now you can speak, sir.
Okay. Right. So today's topic is
Okay.
on introduction to solar Introduction to solar panel installation with Industry 4.0. First of all, I am assistant professor, not a doctor. Okay. Now, basically, first we will see the energy scenario of India. So basically, what happened over here? Uh, the energy which we are using, that is of a primary and secondary type, commercial and non-commercial type, and renewable and non-renewable type. A primary energy source are those that are either found or stored in a nature. Commonly, primary energy source are a coal, oil, natural gas, and biomass. Now, if we see a commercial energy like a petroleum, this type of energy source are available in the market for a definite price are known as commercial energy like electricity, lightning, coal, oil, natural gas, etc. Now, next is a non-commercial energy. The non-commercial energy is the energy that are not available in the commercial market for a price are classified as a non-commercial energy like a solar. Okay. Now, this is the overall energy scenario of India. We are using approximately 5% of our total consumed energy for agriculture, for industry, that is a 49 percentage, for transportation 22 percentage, and for residential 10% and other 14%. Hello, hello, hello. Manish sir, I am audible. Manish sir, hello.
Hello. Yes,
I
sir.
I am audible.
Yes, sir. It is audible, sir.
Oh, okay, right, okay. So here, the sector-wise consumption of energy, that is agriculture, industry, transportation, residential, and other. Like I see here, approximately 50% of our total energy we are consumed in a industry, and in transportation there are 22%. Agriculture only a 5% energy of a total consumption we are using for a agriculture. Now here, this is the globally utilization of energy globally in a year we are using approximately 1,40,000 terawatt hour energy globally. Now if we compare with the Indians consumption, then that is only a 8,000 terawatt hour electricity, or we can say a total energy we are consuming. Now basically what happened, world consume approximately 150,000 terawatt hour per year. The whole energy generated from coal, fossil fuel, and less amount of generated by a renewable energy source. If we compare this consumption with the our consumption, means Indians consumption, then that is only a 7,000 terawatt hour per year. Mostly we are generated this energy from a coal and a natural gas. Now, if we see a present scenario, then just because of digitalization, approximately per we use approximately 4 million song and 7 billion video per day. Approximately we download. Okay. Now this use approximately high amount of energy this required. Now if we see here, uh, by seeing the present population of India, India is going to add 2.5 billion people in the next 30 years. Now, if we want that much amount of energy at uh, 2050, then approximately we have to increase our generation by a 50%, which is now. Now, if we compare this from present scenario, then present scenario is carbon gas in a climate is approximately a 65 percentage. Now, if we match that amount of energy consumption in 2050, then a carbon level in a atmosphere would be a 82 percentage, which is very high. Now, just because of this increasing in the carbon level, the earth temperature will also increase. So to avoid this climate change, in Paris, there is an agreement, Paris Agreement 2016. According to that, every nation has to generate electricity or energy from a renewable energy source. Then they have to increase up to a 37 percentage by 2023. Now, if we see a present scenario of India, then India is generate approximately 23 percentage of its total consumption from the renewable energy sources. Now, if we compare this with the developing country, then according to the agreement, developing country has to reduce their carbon emission by a 2 percentage per year. But presently, the achievement is approximately a 0.5 percentage only. Now, basically, we in India, 65 percentage of electricity we consume from a coal plant. Now, just because of this coal plant, the CO and NOx, SOx, this is emitted in the atmosphere. Now, just see here, approximately we are using a 8,000 terawatt hour per year. Now, although approximately 1 billion home in India does not have a sustainable energy. Now, if we want to match this much amount of consumption, then imagine how much the carbon emission in the atmosphere in a present day. If we match this 1 billion home electricity consumption. Now, here there is some data which based on a installed capacity of India. Now we have approximately coal reserve capacity is of 58,600 billion ton. Oil we have a 786 billion tons, and if we see, then India has a proven natural gas reserve capacity is a 1.05 trillion cubic meter. Now this storage of energy which we have, that is just a 0.59 percentage of as compared to the world. Now we have some data of 1st May 2020, that is before 6 months. This is the installed capacity, and from that installed capacity, this is the renewable energy installed capacity. If we see the installed capacity of India, that is the 3,60,456 megawatt. From that, we have generated approximately 2,27,644 megawatt from thermal. See here, our mostly consumption is coming from the coal power plant. Now, as compared to this, from renewable energy sources, that is just 80,632 megawatt. Now, if we elaborate this 80,000, then from the solar, we have just generated 28,180 megawatt. From wind, there is a 35,625 megawatt. From bio, 9,103 megawatt. From hydro, 4,500, and from wind, 1,3,800 megawatt. Now see here, in 1st May 2020, the generation from solar is lower than the generation from wind, because here what's happen, wind generation is quite your solar generation is costlier as compared to the wind generation. But the installed cost of a wind generation is very high. Okay, because every person from household consumption, they can't install the wind plant because it's costly. But the per unit cost which is for solar is higher than the uh, generated energy from the wind. Now here, this is the generation from a, a total installed capacity and the renewable energy capacity. Now, uh, next is the what is the industry 4.0. Now, the industry 4.0 is referred to the fourth industrial revolution with a growing trend towards automation and data exchange in technology to process through following upgradation in the industry. What happened over here in the electricity generation? If we attach this renewable energy generation with the industry 4.0, then the efficiency of that particular plant or a solar plant or a wind plant or any plant or any industrial thing is increased. Now this industry 4.0 is just based on a internet of thing, then cyber physical system, smart manufacture, smart company, cloud competition, and artificial intelligence. Now, if we see the history of renewable your industry 4.0, then the first industrial revolution is approximately at 18th century. Okay, that is a mechanization through steam engine, water steam were used for iron production, textile industry, and etc. The second industrial revolution take place in an early 19th century. Okay, the third industrial revolution is take place early 20th century when the electronic component is come under the picture, and this electronic component is attached with the internet. So that is the third industrial revolution, and the fourth industrial revolution it take place nowadays where the whole automation is clubbed with the internet of thing, and whole control is done by your mobile. So that is the fourth industrial revolution. Now, the objective of industry 4.0, that is the uh, we uh, going through this for industry 4.0 for achieving shortened time to market, then increase feasibility and boost efficiency. Basically what happened, if any industry is attached with the industry 4.0 norms, then there is just guidelines, not a norms. Each and every company can increase their efficiency, can decrease their consumption of electricity, can increase their production by following the guidelines of the industry 4.0. Now, there are some country which are adopted their manufacturing or their manufacturing for industry 4.0. Then that is an industrial manufacturer in India, Korea, Japan, USA, China, Germany, and Spain. Okay, they follow a industry 4.0 norm for increasing their industrial manufacturer. Then for automobile, Japan, Portugal, Korea, Germany, and South Africa. For then chemical industry, then UK, France, India, China. For a pharmaceutical company, UK, France, India, Spain. And for a electronic, India, Korea, Japan, Taiwan, like other, they follow the industry 4.0 guideline to increase their production. Now, if we uh, see the scenario of India, then government of India is there is one program that is called a Smart Advanced Manufacturing and Rapid Transformation Hub. That is a summer. That is this is a program of government of India. Okay, by which we can increase our export and import by following this Samat guidelines from which is from government of India, and this is looked after by a MNRE. Now, if we see, we have increased our export by following this Samad guideline. Now, here, what happened? We are moving to clubbing the renewable energy source or a generation of renewable energy source by Industry 4.0. By clubbing this, the industry, we can increase the generation, we can increase the efficiency of our solar plant or any renewable plant by following the guidelines of Industry 4.0, and attach that generation with your mobile for that Internet of Things. You can increase or you can take a look after of your whole generation of the plant. For that, the overall generation or overall efficiency will increase of particular plant. Now, there is one block diagram where we are clubbing this solar power plant, wind power plant, then our power plant with the Industry 4.0, and by this we are clubbing all the plant with only with look after by the mobile. Now, in this session, we are going to study about basic component of a solar rooftop plant. Here, I'm going to show you here how a normal residential rooftop power plant is installed, and how we can club this generation to the Industry 4.0, and how we can control the generation of particular plant with the Internet of Things. Now here there is a one single line diagram of the 12 kilowatt solar rooftop power plant. See here, there is a solar panel which is over here. Okay, there is a 12 kilowatt solar power plant. So in a 12 kilowatt solar power plant, there is a two string of a solar power plant, a string 1 and a string 2. This two string individually connected with the inverter, and this is the DC box, DC protection box, then the inverter, then here the AC protection box. Now this generation is go to this solar meter. The solar meter is so how much solar energy generated. Now this solar meter is attached with the this net metering, which is called this is a bidirectional meter. Okay, so the solar meter and this bidirectional meter is the part of a net metering. Now this bidirectional meter is attached to the GB. Actually, we are installed one 12 kilowatt solar power plant at one premises. This is the diagram of that particular plant. This is the electrical diagram. Now, this is the first point for installation of a solar rooftop power plant is a mounting structure. Okay, this is the basic part of the any solar power plant. So here there is a type of rooftop solar power plant structure, that is the roof mounted rack, ground mounted rack, top of pole mounted, fixed standard type structure. This is the fixed standard type structure, and a tracking system mounted rack. Now, in the fixed standard type structure, the solar panel direction is remain steady. Okay, and in a tracking system mountain, your panel is moving as the your sun is moving from a east to west or a west to east. Okay, this slant direction is follow a phase of a south. So this is the fixed standard type structure. This is the structure of a 5 kilowatt solar power plant. Now, As I show you the diagram of this 12 kilowatt power plant, this is the solar module, that how solar module is installed. Basically there is a three type of solar module is there in a market. First is the thin film type, second is a monocrystalline, and third is a polycrystalline type. Okay, each have their limitation and their advantage. Okay, basically from these three, a monocrystalline panel is quite it give a high efficiency as compared to thin and a polycrystalline. Okay, we have installed in this 12 kilo power plant is a polycrystalline panel. Here one panel is power is a 345 watt peak. Okay, and 18 number of solar panel in a string one. As I told you in a diagram, there is a two string. Here in each string there is a 18 panel. Okay, in the that 18 panel is connected in the series with like this 1 to 18. This is the string 1. Now this plus of the string is connected to a minus of the inverter. Oh sorry, plus of string is connected to plus of inverter, and minus of a string connected to minus of inverter. This is string 1 and a string 2. If we multiply this 345 multiply with 36, that is the 12.420 kilowatt. So this is the plant of a 12.420 watt. Now as there is a DC protection box, in the DC protection box, this DC protection box will protect the panel and your inverter from high surge. This is the snapshot of the DC protection box. This is the MCB, and there is a SPD, which is called a surge protector devices. If there is a surge or lightning occur on the panel, okay, so this surge protector device will directly ground the excessive amount of generation, and your whole system will be protected. Now next there is a fuse, okay, which is not shown over here. Now after a DC protection box, there is a inverter. This is the 6 kilowatt string type inverter which has been installed in that 12 kilowatt power plant. There is a two set of the 6 kilowatt inverter. So basically there is a five type of the inverter which we can use in the solar power plant. That is a hybrid inverter, PCU inverter, micro inverter, string type inverter, and the central inverter. From among these five, uh, in today's installation, approximately 80 to 90% of installation is done in this string type inverter. So see here, this is the DC protection box, this is the inverter of a 6 kilowatt, and this is the AC protection box, which is a snapshot over here. This is the AC protection box. In this AC protection box, there is a AC MCB, a surge protector device, and a fuse. Fuse is not over here. Now, here there is a solar meter and a bidirectional metering. Here there is a two snapshot over here. First is of a solar meter, and second is of a bidirectional meter. Now, if we see in this diagram, the generation which is take place by the solar panel, that is of a DC type. Okay. Now this this DC voltage is going to this inverter, which convert this DC supply to the AC. Now this AC supply is going to this solar meter. Now this solar meter is giving a reading of how much AC energy generated from the solar power plant. Now this generated energy is going to the load. There is a AC load like your home. Now, after the generation from the solar power plant, the whole generation is utilized by a household thing, okay, and the excessive supply which is generated by this solar power plant, which is not used by the household thing at particular that instant, the excessive amount of energy is going to the your grid connected supply, okay, and to your electrical board, and that energy which is exported from you to the electrical board, that is noted down by this bidirectional meter as a exported energy. Now there is some situation when your generator is not capable to run the connected load by your home, like after 7 p.m. Now after 7 p.m. there is a no solar, so no generated energy from the solar, and at that time your whole household thing will run by the electrical board electricity. Now that electricity is coming from this electrical board by this bidirectional meter to the load. So that energy is not down by this bidirectional meter as a imported energy. Now at the end of the billing cycle, the consumer has to pay the bill of unit, that is a import minus export. Now suppose for a 2 month, if you have a exported energy, means the excessive energy which is generated by your solar power plant is a 200 unit, and the imported energy which is you have imported from GB, that is just a 250 unit. Okay, so there is a 250 minus 50, that is a 50 unit. So you have to pay a bill of 50 unit only. So that is a concept of a bidirectional meter or a net metering. Now here one thing happen that uh, throughout the year throughout the year, if your consume energy from electrical board, that is equal to the exported energy by you to the electrical board, if that become a zero, okay, then there is a one new concept come under the picture, that is a zero energy building. Now, in Gujarat, there is a consultant like me who give a advice, or who give some solar power plant installation or wind power plant installation to make any building as a zero energy building. A zero energy building means energy which is generated, which is consume electricity, okay, and energy which is given by that particular building to the electrical board, these both are same throughout the year. So that is called a zero energy building. Now after this generation, okay, this is the solar meter. This solar meter is note down the how much energy is generated by a solar power plant. Okay, now this solar power plant, this energy is going to uh, household thing, and which is connected to this your electrical board meter. This is the bidirectional meter or a net metering. Now here I am clubbing this generation of solar power plant to the uh, internet of thing, or this whole generation you can observe by this mobile. This is the IoT based surveillance. In mobile there is an application by which you can look after the whole generation. This a current generation, this is the plant of a 3 kilowatt power plant, this is the current generation. Now this is the daily generation, 1.53 kilowatt hour, okay, this is total generation 342 kilowatt hour means unit, okay. Now here man, I hope you. See here, wait for a minute. This. There is one application which is called as Solar Man. There is one consumer Premila ban. This is the total production. See here. Here, the consumer can observe their total generated energy. See here, this is the daily production, a 2.75 kilowatt hour. Okay, there is a total generation till now, which is the 337.95 units. Actually, before a 2 month ago, this power plant is installed. Okay, now if you want to see, look after the month wise generation, means monthly generation, daily wise, then see here, this is the generation of 1st October and this is the generation of 29 October. See here, till now, the generation is a 3.1 kilowatt hour, means unit at 2 p.m. Okay, see here, there is a 8 unit daily, there is a generation of daily basis, and if the consumer want to observe a current generation, then see here, this is the current generation graph. It is started from morning 6 up to 2. Now this graph is very from as depend on the atmospheric condition. Okay, so by this way we can club our solar generation to the industry 4.0, means by the internet of thing, and from this we can observe the generation or a condition of our solar power plant. Okay, see here, if there is any error or any fault in the power plant, then you can check that in a alert. If there is some problem in a power plant, then this there is one alert which show over here, and you can clear that fault by online. There is no need to go to the plant and solve the problem. You can solve the problem by software, by this app. Okay, you can observe the your device. See here, this is an inverter. Okay, current generation is a 150 ohm. This is total generation. This is the logger data. You can look after everything. This is the network connection. If there is a connection is zero, then there is no internet connection. Then in the power plant generation, there is a show you a zero, and in an alert there is a error is coming by the device. So by this internet of things, you can observe your whole solar power plant by this solar man app. There is a many app like a smart client. This is a solar man. Okay, then there is a uh, your solar app. There is a number of app which is in a market. You can install that and you can look by this app. Now, in this session, if anyone have any doubt, then he can ask.
Hello, sir.
Yes.
Thank you so much, sir, for sharing this information. Do you want to continue further? Or
No, actually, if anyone any doubt, then we can conduct this question answer session.
okay, sir. Actually, we have this being shared on the YouTube. I'll just see
Okay.
in the YouTube if there's any question. I'll let you know.
Okay. Okay.
No, sir, I don't think there's any question on the YouTube. So I'm
Okay.
very thankful for you to accept our invitation and be available to us for in a very short span of time. Thank you very much for sir for this valuable information that you have passed on to us. Thank you so much, sir. Thank you.
Okay. Okay. Thank you.
Thank you, sir.